We are in SimAUD2018, which is the Symposium for Simulation, Architecture and Urban Design.
This conference brings together people who have a passion for simulation, who are truly simulationists, and who are very much interested in sharing all of those details to further the quality of our practice.
One of the key aspects, I think, is the interdisciplinarity. It takes together architects, engineers, professional academicians.
At the core of SimAUD, it was not just the advancement of science and technology and understanding of simulation. It was also about building a community around this important topic.
Now, the people that do simulation in architecture have a place to gather once a year and discuss their new ideas and move the field forward.
I think the true role for simulation to support architectural practice is informed design. First and foremost, needs to be able to integrate into the design process to enable designers to make smarter decisions, to understand how the decisions that they're looking at informs performance.
Architects and engineers are trying to design these complex systems. They have many unknowns, and they have to come up with solutions that will work for a wide variety of stakeholders. So simulation lets them look at all those interactions.
Simulation tools can give us information about what we either haven't built yet or what we cannot calculate directly yet, and therefore become very useful and a rich resource to enable you to make more informed design decisions.
The most exciting aspect of computation tools is the way in which they expand the capabilities of the human mind. The place where I find that tools help me the most is in fact sort of upside down or backwards, because when I think about the tools, more often than not it helps me come up with new problems that tool can define.
They have a great learning capacity by being able to teach people through a direct visualization channel the impact of data. Being able to interact with data, understanding how different variables impact different outputs.
There's a bidirectional relationship between the university or the academy and the industry as it relates to simulation. Simulations need ground truths and validation, which the university is well suited to do as opposed to industry. And industry provides great feedback to those that are developing simulation tools and simulation theories.
And there is an increasing emphasis on the early design phase, where really the most relevant decisions are actually being taken.
We have parametric design and dominance of performance-based simulation in early design stages, but we also are seeing growing fields such as the use of machine learning and urban scale research.
Our growing ability to collect data from our environment is going to have a major impact in how we use that data to inform our future simulation tools. There are new advancements in machine learning, AI, that are also going to completely change in how do we do those type of computation that were done previously in using other simulation models.
It used to be that there was sort of one tool that you tried to do everything, and I think more and more it's becoming these bits of tools that you can put together kind of like a toolkit. It's about using a toolkit that you can kind of put together in a way to answer your unique problem and question that you have.
Design is something which is every time unique, and I think that the world of simulation is somehow understanding and evolving that direction, allowing for increased customization.
We've gone beyond the energy paradigm where we're concerned solely with the performance of a building as an envelope and how it acts with different fluid systems. We're moving more into issues of complexity related to how humans occupy the built environment, how their behavior can be linked to different performance outputs, and ultimately how those performance outputs can drive much larger impacts with respect to productivity and well-being.
One of the biggest stumbling blocks in many computational tools now is some of them take days to weeks to process. As with every form of computation over the past decades, just the speeding up of the systems has to some extent expanded our capabilities.
And I think that just the computational abilities in general of being able to run, say, thousands of simulations just overnight allows us to understand problems in a kind of larger space than we would have when you had to run one simulation, wait a day, change one parameter, run one simulation.
We can continue to see a trajectory where our tools become much more accessible, much more open, and hopefully much more meaningful to creating actionable outcomes in the built environment.